All right, lecture 31. You should know those terms. Now, the first question here is, or what they want you to do is finish each precipitation reaction and write the complete ionic equation and net ionic equation for each. All right, now, this is where students get really kind of confused. I'm gonna, yeah, good. I have a second copy here. So first, you have to determine if these are aqueous, because if they're not aqueous, then they can't react together. They should be, but you always want to go back and check. Magnesium chloride, chlorides are aqueous. Magnesium is not one of the exceptions. Silver nitrate, any nitrate is going to be aqueous. So they break up into their ions. So this isn't how I'm going to solve the problem. I'm just doing, I'm going to use this second copy I have here, a first copy, and then go to a second copy. But, whoops, let's break them up into their ions. Just to see. So students will look at this and say, well, how do I know what reacts? Okay, well, we have a limited number of choices, even though I think when students see it, and I'm trying to think back to when I was a student, it seems like, well, there's so many possibilities here, so many variables. But really, if we look at magnesium, we know that these ions, two of them are going to combine to form a precipitate. That's how it always works. So magnesium, will it react? What can it react with? Would it react with the chloride? We know that it doesn't. How do we know that? Because it went into solution as an aqueous compound, or a soluble compound. So when it goes into solution, it breaks up. So there's no way that it comes together. So we can just skip that. Magnesium is not going to come back together with the chloride and precipitate out. It already, by being a soluble compound, we know that it doesn't do that. So that's gone. Magnesium and silver, they're both positive charges. There's no way they're going to come together. We can't produce magnesium silveride or whatever it would be called. It's not going to happen. The only thing that could react with is the nitrate. And then we know that nitrates are always soluble, so nothing happens there. So, well, it seems like nothing's happening. Well, look at the chloride. The chloride, will it react with the nitrate? No, it can't react with the nitrate because they're both negative charges. So we have these two, silver and chloride. Look at silver chloride in your solubility chart. You see that it is a solid, and that's what you're going to find. You're going to find that you're going to produce one of the two of the ions are going to come together to form a solid. So let's go to a clean sheet here. Yeah, here it is. So just complete the thought here. So we have magnesium chloride is aqueous, silver nitrate is aqueous. We know that we check out all the ions, all the possible combinations. The only one that will produce a solid is the silver chloride. So it means that you need to know your solubility rules very well. So the first thing, these should be aqueous because that's how you start a reaction, but double check, make sure. And then we know that we get silver chloride, solid, and then we get magnesium nitrate. The last thing that we have to do is we have to make sure we balance the equation. So this would be 2 and 2, and you should know how to balance the equations. Okay, now we can finish the precipitation reaction and write the complete ionic equation and net ionic equation. So now we have to go through magnesium, do what I just did, but without all the extra explanations here. Just breaking up the soluble ones on the one side. The ones on the left side will always be soluble, whether they're ionic or molecular. There's going to be one compound on this side that's going to be solid for a precipitation reaction. And then what I do is I circle the spectator ions. They don't say to do that, but it's good to keep track of them, the nitrates. And we see that what we end up with is 2Cl plus 2 silver. And there's a little something special about this here. Because the net ionic equation, now that we've gotten rid of the one ion, the ones that had ones in front of them, we just have twos, we would then reduce this down to this form. And this is the way, you don't want to leave it with a bunch of twos in there. If everything can be reduced now, because the magnesiums are gone, you want to reduce it. Now, some students will ask, is it okay to leave it in this form? Certainly. The chloride and the silver are not in any form in the solution, but a lot of times people will switch it around just because it makes it a little easier to look at. Nothing wrong with this. Or nothing wrong with this form. It's just two reacting ions form silver chloride. We definitely have to have the ions on the left and the precipitate on the right side of the equation, but other than that, you can mix and match them around as you want. Okay, now we'll go a little bit faster. We verify that this is aqueous, this is aqueous. We see that we'll produce sodium sulfate, which is aqueous, and then aluminum hydroxide, which is solid. And then we have to keep track here, so we have 3. So we have 3 here. This would be a 6. This would be a 2. Oh, it's trickier than I thought. Not too bad, just gotta be careful. So 2 aluminum, 6 sulfates, 6 sodium, 6, yeah, so everything's there. Now we have to break it, so the complete ionic equation is 2 aluminum. We know it breaks up into these ions because it's aqueous. We double checked it with the solubility rules, but you should know those right off the top of your head. There aren't that many. You should be able to do them really quick. Whoops. 3 sulfate. 2 aluminum hydroxide, which is got so used to breaking them up into the ions, but this is solid, so we leave it alone. Now we have sulfates that do nothing. Those are our spectator ions. Sodium does nothing. So we have 2 aluminum plus 6 hydroxide ions produce 2 aluminum hydroxides. And again, these are long problems, so from time to time I'll check to make sure I'm on the page. Oh, good, I am here. So this is the net ionic equation. So circle the spectator ions. You don't have to. I do, just so then when I go back to write the net ionic equation, I just write off what's left over. Makes it pretty easy. Okay, keep going. Sodium chloride, should know that's aqueous right off the bat. Then we have iron 2 nitrate, which has to be aqueous. This is going to produce iron 2 chloride and sodium sodium nitrate. Now if we look at the rules, iron 2 chloride is aqueous, as is sodium nitrate. Now we haven't balanced it, but we don't really need to because everything is aqueous means there's no reaction. And you should get used to the fact me using NR for no reaction. That comes up a lot, and that's what I do to abbreviate. Don't normally write out no reaction. No reaction. So we can't do anything further. And on my exam, if I did this, I'd have that as an option. So you wouldn't have to feel like, well, what am I supposed to do now? I'll say, if there's no reaction, write NR. Okay, so barium nitrate, definitely aqueous. Potassium sulfate, potassium tells you that it's aqueous, so does the sulfate. We have barium sulfate. If you look in your table, you see that this is insoluble, so it's solid. It's unfortunate that soluble and solid begin with an S, but that S means solid means that it's insoluble. It falls out of solution. Then we have potassium nitrate, and there's going to be 2 of those. So make sure everything's balanced. Good. Now this is barium. This is 2 nitrate, 2 potassium, 1 sulfate. On the other side, barium sulfate stays as a solid because it's insoluble. Here's some ions, a couple more ions, potassium. Now, potassium ion is doesn't do anything, so it's a spectator ion. Nitrate ion does nothing. So that's the complete ionic equation. The net ionic equation is this. So even though I'm not labeling them as complete and net ionic equations, I'm saying it out, and you know the trend. So make sure, just to finish it up. Should label it, even though I'm saying it out, but there we are. And then the last one here, nickel 2 chloride. Chlorides are aqueous. Sodium bromide, definitely aqueous. This would be a 2 here. Then we have 2 sodium chloride which is aqueous, and then nickel 2 bromide. And nickel 2 bromide is aqueous as well. Not sure why I put this. I think I forgot that I had one up above that was already this. This is no reaction. So yeah, I think I just tagged this one on because I thought I didn't have one like that in here. But these are the C and E are both no reaction.